Hi guys, hope you're doing well. It's Friday before the long weekend and I'm looking forward to a long weekend, as I'm sure you are too. I wanted to just do a video on question number 1 in exercise 8F because there can be a little confusion about quartiles, finding quartiles when you have an even number of data values in the set. So I'm going to go through each question. I'll show you what I mean. So the question is about the depths of snow at a ski resort, which are collected for 12 years on January 31st, and all data is in centimeters. So what I've done, first of all, is just reordered the data from least to greatest. Usually that is helpful. You don't have to do it, but it definitely does help when you're looking at the data to make your calculations. Just to note that you should be able to do these questions with and without the graphing calculator. So you should know how to do both. I've given you instructions on how to find the mean and median in last lesson on the graphing calculator, and you will get the quartiles in that same set of results that the calculator gives you back. So just follow those same instructions. But you should also know how to do it without a calculator, so that's what I'm going to do right now. And of course you can always check your answers with the calculator as well. Oops, screensaver went on there. Okay, so first part A, find the range. So range is always the difference between the maximum value in the set and the minimum value. So in that case, in this case, the maximum value is 125, the minimum value is 30, so the range is 95 centimeters, since all the values are measured in centimeters. And for the median, so the median is always the middle value of the set, but when you have an even number of values like this, there's 2, 4, 6, 8, 10, 12 values altogether, then the median is going to be the average or the mean of the two middle values. So the two middle values here are this 65 and 70, because then there are 5 to the left of it and 5 to the right of those two values. So we have to average those two values, so it'd be 65 plus 70 over 2, which is 67.5 centimeters for the median. And then for part C, it asks you for the lower quartile, which is Q1. So you have a formula in the textbook for the lower quartile, which is the lower quartile is found at 1/4 of the n plus 1th value. So what that means is we just put n, which is the number of data values in for n, which is 12 in this case. And 1/4 of 13 comes to 3.25. So what that means is that Q1, the lower quartile, is found at the 3.25th value. Now obviously the 3.25th value doesn't exist. So here's where some confusion comes in. Let me go to the next page here. So we're going to do this again. See, we got that Q1, let me just write Q1 here, should be the 3.25th value in the data set. The third value in the data set, let me just go back. So the third value is 55, and the fourth value is 60 when you order them from least to greatest. Now, I remember doing this in a different way than how the textbook does it, and what I found out is how it's done in general on the IB exam. So first I'll just show you how you should do it for the IB exam. So what this actually means is the Q1, the lower quartile, is the median of the set of data that's below the median. So it's like a median of that first half of the data. So what you want to do here when you get 3.25 value for Q1 is simply do the median of the third and fourth values. So you would just do 55 plus 60 over 2, which comes to 57.5. Okay, so that is your Q1 value for our purposes. However, to me it wasn't making sense because it doesn't say that it should be the 3.5th value, which would be halfway between the third and fourth values. It says it's a 3.25th value. So if you look this up on the internet, you're going to find all sorts of different formulas and disagreement about how to find Q1. Another way to do it, which would be actually more precise, would be to actually go a quarter of the way between these two values instead of just halfway between them. So to do that, you would have to do the third value, which is 55, plus 1/4 of the difference between the two values. Okay, and that would come to 55 plus 0.25 times 5, 56.25. So if you start looking up stuff on the internet about Q1, you might find a formula that leads you to find the first quartile here to be 56.25 instead of 57.5. Both methods are correct, but they're used in, I'm assuming that this method is used in more advanced statistics. So maybe if you take a statistics course in university, you'll use it. But for our purposes, we're just going to stick with Q1 is the median of the third and fourth values, which means the average of the two. And that's because when we did the formula for Q1, we got a number that was in between the third and fourth values. Okay, so we're just going to go with the median of the third and fourth values. Hope that's clear. If not, then please inquire with me directly. Part D asks you for the upper quartile, which is Q3. And so for our purposes, Q3 is the is 3/4 of the n plus 1th value. That's the formula that you have in your textbook. Now just note that this is giving you which value to look at for Q3. It's not actually giving you Q3, right? So 3/4, that would be 3/4 of the 13th value, which comes to the 9.75 value. Again, in more advanced statistics, you would go to 3/4 of the value between the 9th and 10th values. But for our purposes, this is going to mean just do the median, sorry, slip there. Just do the median of the 9th and 10th values, since Q3 is between those values. So the 9th value is 75 and the 10th value is 110. And so we just do the average of those two, which comes to 92.5. So Q3 for our purposes is 92.5. Part E asks for the interquartile range, which is just the difference between Q3 and Q1. So that's 92.5 minus 57.5 in this question, which comes to 35. Last step is to draw the box and whisker plot. So for that we need our 5 statistical summary, which is the minimum value, 30, the maximum value, 125, Q1, which we calculated to be 57.5, Q3, 92.5, and the median, sorry, I forgot the median in between. Median, which is also sometimes called Q2, is 67.5. Now just to note that if you use the graphing calculator to do Q1 and Q3, these are the answers you're going to get. So the graphing calculator is also doing the 3.25th value as the median between the third and fourth values, rather than using the other formula I showed you. And same with Q3. So box and whisker plot, look at your values and see what kind of scale makes sense for the box and whisker plot here. I'm going to go by tens, I think, if I have space to do it. So the min value is 30. Actually, I don't have room to do it. I'm going to go by 20s. And I need to go as low as 30 and as high as 125. You first thing you do is put your min and max values on. So 30 would be halfway between 20 and 40. This is my min. And then 125 for my max. So it should be a quarter of the way between 120 and 140. Approximately. It's a little hard to show on here. Okay. And then I put on Q1, median, and Q3. So Q1 is 57.5, somewhere around here. Q3 is 92.5, a little bit higher than 90. And median, or Q2, is 67.5, so somewhere here. Okay, and then what you do is you join, sorry, it's really hard to do what need on here. Let's try that again. You join up Q1 and Q3 and the median to make a box, and then you just put a line to the min and a line to the max from there, which are considered the whiskers. Okay, you can also use the graphing calculator to get a box, to make a box and whisker plot, and I put a video in the lesson with instructions for that, which is, the video is really clear because it shows screenshots of the actual calculator. It's kind of neat, but I don't find it that helpful because the scale on is not that clear on the calculator. So if you want, you could use it just to kind of check your box and whisker plot, but I find that it's better to do the box and whisker plot by hand.